Hello, welcome to the course Internet of Things. I am Mrs. Muthulakshmi, Assistant Professor of Computer Application, Standard 5 of Rajaratnam College for Women, Sivakasi. In this course, we are going to learn the definition of IOT, components of IOT and what are the characteristics of IOT, logical and physical design of IOT. IoT is nothing but a system of interrelated computing devices, mechanical and digital machines, objects, animals or people provided with a unique identifier, and it can ability to transfer data over the network without requiring a human to human or human to computer interaction. These are the components of IoT. IoT is nothing a group of devices connected through the internet and can transfer data through the gateway and stored in the cloud for further analytics, and it can interact with the user through the user interfaces for further processing. Then these are the characteristics of IoT, and the IoT devices must be a dynamic and self-adapting, self-configuring. It must be interoperable with the communication protocols. It must have a unique identity and it have to integrate with the other information networks. Then these are the physical design. IoT devices can exchange data with the connected devices and application through directly or indirectly. It has to collect the data from other devices and process the data locally or send the data to the centralized server or cloud based on the applications. It may be a backend or in the cloud. It performs some tasks locally and other tasks within the IoT infrastructure based on its temporal and space constraints. This is the physical design of IoT. The IoT device may consist of several interfaces for the connection to the other devices. It can be a wired or wireless. IoT interfaces for sensor, interfaces for interconnectivity, memory and storage interfaces, and audio and video interfaces. These are the protocols needed to connect IoT infrastructure with the network. Link layer, in this link layer we can use Ethernet, Wi-Fi, WiMAX or LR, WPAN LAN, 2G, 3G or 4G protocols. These are the later IEEE extensions. Then network and internet layer. In this layer we use IPv4, IPv6 and 6 low PAN protocols. In transport layer we use TCP and UDP protocols. In application layer we use HTTP, COAP, WebSocket, MQTT and XAMPP DDS protocols. Logical design of IoT. Logical design is just the abstraction representation of entities. The process without going to lower level specifies of implementation. It is just the member of functional block that provide the system the capabilities for identification, sensing, activation, communication and management. This is the block diagram of logical design. Next we move into the what are the communication models in IoT. There are 4 basic communication models in IoT. They are request response communication model, publisher subscriber model, push-pull model and exclusive pair model. We see one by one. Request response communication model. In this model the client sends the request to the server and the server responds back to the request is. The server receives a request, it decides how to respond, fetch the data, retrieves resource representation, prepares the response and send back to the client. In publisher subscriber model, it involves brokers and consumers. The publishers are the source of data. The publisher sends the data to the topics which are managed by the broker. So, broker is in between the publisher and the consumer. The publisher not aware of consumer, they are not directly connected with the consumer. The consumer subscribe to the topics which are managed by the broker. When the broker receives the data for a topic from the publisher, it sends the data to all the subscribed consumer. See the diagram, the publisher and consumers are not directly related to each other. In push-pull communication model, the data producers push the data into the queue and the consumer pull the data from the queues. The producers do not need to aware of the consumer. The queues help in decoupling the message from the producer and consumer. The queues also act as a buffer which helps the situation when there is a mismatch between the rate at which the producer pushes the data and the rate at which the consumer pulls the data. Full duplex, the communication model that causes the persistent connection between the client and the server. Once the connection is set up, it remains open until the client sends a request to the close the connections. Here it is a fully connected. Once the connection is established, we can transfer any number of data and finally close the connections. In exclusive pair model, the client and server can also send the message to each other after the connection setup. Conclusion. The scope of IoT is not limited to just connected things to the internet. The application of IoT can extract and create information from the lower level data by filtering, processing, categorizing, conditioning and contextualizing of the data. Choose the best model is the first step in building the efficient IoT applications. Thank you.